Hello, this is the first of a set of 5 lectures on the very basics you need to know about climate change if you want to study climate change and health. So don't worry, I'll only give you the very basics and there will be no formula, which I don't understand myself, by the way. So the weather, we need to know what weather is and what climate is. The weather is, if you look out of the window, that is the current state of the atmosphere. It may rain in your place, it may be at night, it may sunshine, maybe sunshine. That is the current state of the atmosphere. Whereas climate is only different in the time span you make an average of weather. So climate is the average weather, the average state of the atmosphere over more than 10 years. That is very important to know because it's much more difficult to have a weather forecast for 1 minute in each square meter, in each place and altitude, if you like, even, for 3 days than to have the average over 10 years, even in 100 years. This is a completely different way of projecting weather versus climate to the future. There are 9 key characteristics for both: temperature, rainfall, humidity, evapotranspiration, wind speed and direction, sunlight irradiation coming in and sunlight reflection coming out of the Earth. That's also called albedo, and air pressure. So now you understand what weather and climate is. The next thing we want to understand is what the atmosphere is. The atmosphere is a Greek word. It means the envelope of gas around the Earth. And that's about 10,000 kilometers high. Here you have the entire column to the right. But the climate is happening and the weather is happening at the very lowest part, called the troposphere. That's where the greenhouse gases are. The stratosphere above, that's where we have weather balloons, that's where the ozone hole is, or where the ozone layer is. So these lower parts of the atmosphere are important for weather. Now, everybody, I guess, has heard about the greenhouse effect in school or in the media. In short, a greenhouse, of course, is a house made of glass in which you can grow tomatoes, for example, in the winter. And you can do this because the sunlight gets in and doesn't get out again, partially at least, so it keeps it nice and warm inside. And this graph depicts this as if there were a glass ceiling at about 10 kilometers of height, which has the same effect. In fact, there is no such a thing as a ceiling. It's just the entire gaseous envelope that makes the greenhouse effect. So it keeps the Earth much warmer than it would otherwise be. In fact, without the greenhouse effect, we couldn't live on the planet. But mankind has tampered with this effect by sending gases in the atmosphere that increase the greenhouse effect. And now, what are these gases? I only give you the main gases. And this is, of course, carbon dioxide. You see the upper line, the largest contribution. Then methane, which is produced by animals and by plants. Black carbon, not so very well known. We'll get into this in one of the future lectures. Holocarbons and nitrous oxide. The last one is known from diesel trucks that do not use purifying urea. Talking only about gases that are emitted leaves 1/3 of the climate change unaccounted for, because deforestation and land use changes account for 1/3 of excess emissions. And you can understand this as one is sources of CO2, for example, and the others are sinks. They absorb. So the rainforest, as you all know, the lungs of the Earth, they absorb CO2. And if mankind cuts them, it cuts the ability of the biosphere to absorb a large amount of CO2, and that's as if we leave more in the atmosphere. So 1/3, keep this in mind, 1/3 of the excess emissions are due to decreased sinks. That means deforestation. Now, what are the dimensions of climate change? In the newspapers, you read this interchangeably with global warming, which is wrong. Warming is just one of many facets or parts of climate change. The other one is changes in the rainfall system. Some areas get more, some areas get less rainfall. Then the oceans, they rise, they get higher, warmer, and more sour. Warmer is understandable if the atmosphere gets warmer, and then also the ocean gets warmer, but it also gets more sour because of the CO2 which is dissolved in the water now. And all this is not good for fish, it's not good for the oxygen content, and it's not good for the coral reefs. The fourth component you've heard about as well, melting of glaciers. Think about the Himalayas as feeding with water, supplying with water about 1 billion people, north to China, south to India and Bangladesh. And they are melting, they are diminishing in size. There are more, these are the gradual changes. Then we come to the extreme changes of weather, and here we have heat waves, floods, storms, landslides. So not only is there a gradual increase in, let's say, temperature, but temperature comes in violent extremes. Heat waves, but also cold waves for a while. Now, the last type of climate change is very often confounded with increase in extreme weather events. It's a higher probability of abrupt climate change. These are singular events that, if they happen, have a huge effect on the entire globe. And the next slide shows you two types of them. One is the Gulf Stream can stop. You know, the Day After Tomorrow film. That is when this huge temperature equalizing system of ocean currents stops all of a sudden. Then in Europe, Northern Europe, it will become several degrees colder within years. And in other parts of the world that are already hot, it will become much hotter. We don't want to have this. It has happened in the past. It can happen, but nobody knows when. We only know that the probability of these abrupt changes becomes higher as we pump more and more energy in the atmosphere. Another abrupt climate change is the falling down of the Antarctic ice sheets in the water. You know that the Antarctic is a continent, but there are ice shelves that are hanging above the waters, and if they fall down, there will be a huge rise in sea level between 6 and 60 meters. These changes are of low probability, but the probability rises as mankind pumps more and more energy into the atmosphere. This is the end of this lecture. In the next lecture, we will see that climate changes are not the same everywhere on the planet. There are huge differences, and we are going to look into this, and we will also project climate changes in the future and see what scientists hold in store for us. And stay tuned.